Hello, I'm Dr. Harper. This video is a homework Excel tutorial video in Linear Programming Operations Management, Part F. So let's bring up the problem. A product mix problem. A small company manufactures 3 sizes of their picture frames that require the processes of carpentry, finishing, assembly, and packaging. Each process resides in a department that works in 8-hour shifts. The production standard in each department is reported to be the number of products produced during a fixed production time. The production standard in the carpentry department is reported to complete 20 small frames in 2 hours, 32 medium frames in 4 hours, 12 large frames in 2 hours. The production standard in the finishing department, let me underline that. Here is the carpentry department. Let me underline that. And let me return. And then the production standard in the assembly department. Let me underline that because we're going to have to bring these into Excel in a minute. And then the production standard in the packaging department. Underline this. So there's 4 different departments. And so the profits are $8 for each small frame, $10 for each medium frame, and $14 for each large frame. Assume all frames are produced and will be sold, and each frame has a minimum production requirement of $6. Let's underline that. And let's show profits, and let's underline those. And so up here, each profit resides in a department that works on 8-hour shifts. And let's underline that. That'll be important. And there we go. So those are the important parts. What is the maximum profit for one shift? Okay, so let's bring up Excel and let's solve this in Excel. Now that we have this, there's no template, so we have to build our template. Let's come down here a ways. Okay, and let's put the, let's start right here, and let's put the different departments. Carpentry, and then finishing, assembly, and packaging. There we go. Okay, so that's that. Now we're going to have, on each one we have the small frames in hours, medium frames in hours, large frames in hours. That's our standard. Okay, and so therefore what we want to do here is put both of these down to create our standard. So this is frames and this is hours. And so this is going to be small, and over here is going to be medium, and over here is going to be the large. And we want, let's just put all this data in here so we can start using it. Okay, and so right here, let's begin to use it. Let's reduce this down. Bring this down. Okay, carpentry, and here it comes. Let's make this a little bit larger. Okay, let's put the frames and hours for carpentry. Okay, here we go now. Okay, carpentry. Okay, 20 small frames in 2, 20 in 2 hours, 32 in 4 hours, 12 in 2 hours. Okay, and I hope I got that right. 20 in 2, 32 in 4, 12 in 2. Okay, good. Now the finishing department is 24 in 3, 15 medium frames in 3 hours, and 20 large frames in 4 hours. Okay, now the assembly, let's bring this down. Now the assembly department has 8 small frames in 1 hour, 16 in 2, and 12 in 3. So this is 8 small frames in 1 hour, 16 in 2 hours, and 12 in 3 hours. And finally the packaging is going to be, oh, I did the packaging. There we go. Bring that down to packaging. Now the assembly up here is going to be 24 in 3 hours, 32 in 4 hours, and 10 and 2 hours. Let's make sure we got these right. 24 assembly, 24 and 3, 24 and 3, 32 and 4, 32 and 4, 10 and 2, 10 and 2, 8 and 1, 8 and 1, 16 and 2, 16 and 2, and 12 and 3, 12 and 3. Okay. And then up here, we have 8-hour shifts. So now let's actually, before we do the rest of it, let's come down here and let's take the, and let's build our matrix. Bring this down here, and there it is. And let's have our small, medium, and large right here, and bring these together. And then down here, this will be our profit. And so I think we do have our profit down here. Yep, 8, 10, and 14. And this is going to be 8, 10, and 14. And over here, our capacity in hours, these are in hours, so let's use our capacity in hours. And it's at 8-hour shifts. So our capacity is 8 hours for each of the departments, because 8-hour shift is one production run. And let's see, a minimum production of requirement of 6, okay? So let's go ahead and bring this out here. Now let's have a minimum production of 6. Very good. Now we're going to have an optimal mix right here. So let's go ahead and let's box this in like we have before. And let's shade this to make sure that we remember that this becomes our decision variables. Okay, and there's our setup. Now we just need our values. Which is this? Oh, we need to get these values in here. Okay, remember these numbers in here are production standards, which means the number of units of resource for each unit of output. Well, a resource is hours, and these are hours. So it's going to be hours per unit. So this simply will equal 2 hours per 20 frames, and it's 0.1 hours per frame. So that's hours of resource for each unit of output. Same for medium. That's going to be 4 divided by 32. And the large will be 2 divided by 12. And we can copy these down, and that's going to be our production standards. Now let's do our values. Equals the sum product of our coefficients right here times our optimal mix right here. That's our variables. F4 to freeze that. Okay, and I messed up. Comma our optimal mix. I thought that was wrong. F4 in parentheses. And let's go ahead and look at this. And sure enough, D12 through F12, that's the blue, comma, D18 to F18, that's the red. We're going to multiply those, sum product, and then copy these down. Finishing, assembly, packaging, and the profit. So that right there, box that in, there's our objective function. So I think we're ready to go. So all we do is our data, solver, our objective function is going to be that cell right there. We want to maximize our profit by changing the small, medium, and large number of frames we're going to produce, because that's our product mix. Add constraints. Well, the values here of what we're using must be less than or equal to the capacity of 8 hours. Add also our optimal mix must be greater than or equal to the minimum production of 6. Now I could have just typed 6 in there, but I'm doing it this way to be complete. Okay? Non-negativity constraints, make sure this is a linear program because it's a linear model. Solve this thing, and sure enough, solver found a solution. All constraints and optimality conditions are satisfied. Keep solver solution okay. And it's 506. Bring this back down. 506, and that's what we got, 506. What is the profit of producing 1 dozen of each product for 1 shift? Oh, well, that's straightforward. Production mix, 12, 12, 12. And right here, that simply equals the sum product of our profit coefficients here, comma, our production mix. Return 384. Let's box this in and shade it. And sure enough, 384. And that's all I have for this homework Excel tutorial part F. Until the next time I see you, take care.